Hello students, in today's video I would like to discuss about the physical quantities. My dear students, the quantities which are specified by their magnitude are called the physical quantities. The physical quantities are classified into scalar and vector quantities. What are the scalar quantities? The physical quantity which can be specified by its magnitude only is called a scalar quantity. Once again, the physical quantity which can be specified by its magnitude only is called a scalar quantity. For example, distance, speed, pressure, work, energy, etc. These physical quantities have no direction, they have only magnitude. Suppose distance, we specify the distance of a body in certain meter or certain kilometer, but distance does not show the direction of the body in which it moves. Now again, vector quantity, a physical quantity which can be specified by the magnitude as well as direction, both is called the vector quantity. For example, displacement, velocity, acceleration, force, etc. These physical quantities have magnitude as well as direction both. Magnitude means they have certain values. Says for example, displacement of a body is suppose 100 meter. This is the magnitude, that is 100 meter, and in a specific direction, that is the direction, so it is a vector quantity. Next topic is speed. The distance traveled by a body per second or per unit time is called its speed. It is expressed by letter v, small letter v. Speed is equals to distance traveled by time interval. So v is equals to s by t, where s is the distance traveled and t is time interval or time taken. Now some features of the speed of a body. Speed is a scalar quantity, means it has only magnitude. The SI unit of the speed is meter per second, and other units are centimeter per second, kilometer per hour, and some other unit may be taken. Another feature of the speed is, since distance traveled by a body is always either positive or zero, therefore speed of a body is also positive or zero. It means speed of a body can never be negative. Now types of speed. The speed is of different types, so we classify as one of them is uniform speed. When a body covers equal distance for equal interval of time, howsoever small time interval may be, then its speed is known as the uniform speed. Dear students, here the time is very important to describe that speed is uniform or not, because sometimes certain examples we observe that the body seems to be in uniform motion, but it isn't true. For example, in my previous video I explained about the motion of the earth around the sun. As the earth moves around the sun in an elliptical path, not in a circular path, so its motion is not uniform. It does not take equal interval time to move the equal distance. Therefore, the motion of the earth is not considered as uniform motion. Motion of the object which covers equal distance for equal interval time. For example, motion of the car on a straight road with a constant speed. Now take an example of the position time table which can specify about the uniform motion. Says in this, the time interval taken as 0, 5, 10, 15, 20, 25. And in this time interval, the position of the object is 0, 10, 20, 30, 40, 50. Now we find the speed. So here in first 5 seconds, the speed of the object is 2 meter per second. Then after 10 seconds, the speed again 2 meter per second. After 15 seconds, the speed can be calculated 30 minus 20 by 15 minus 10. This gives us the value 10 by 5, and this is equals to 2 by 2 meter per second. Then after 20 seconds, the position of the object is 40 meter. So here speed will be 40 minus 30 by 20 minus 15. This is how much? 10 by 5. This is equals to 2 meter per second. Next is after 25 seconds, the position of the object is 50 meter. Here the speed will be 50 minus 40 by 25 minus 20. This gives us 2 meter per second. So my dear students, as you see that here the speed of the object is always 2 meter per second. This is an example of the uniform motion. Next we take here the example, the non-uniform motion. If a body covers unequal distance for equal interval of time, then its speed is called the non-uniform speed. For example, the motion of a car on a curved road or zigzag path is gives the non-uniform speed. Just to take an example of this time position table, and we find the speed of the object. The time interval is taken as 0, 10, 20, 30, 40, 50, 60. And position of the object is 0, 20, 30, 45, 70, 100, 150. Now we are going to calculate here the speed. So after 10 seconds, the speed is here 20 minus 0 by 10 minus 0. This is 2 meter per second. Next, after 20 seconds, the speed of the object is how much? 30 minus 20 by 20 minus 10. This gives us 10 by 10, that is 1 meter per second. So earlier the speed was 2 meter per second, now it is 1 meter per second. Next, after 30 seconds, the position is 45. So here speed will be 45 minus 30 by 30 minus 20. This gives us 15 by 10. This is equal to 1.5 meter per second. Next is after 40 seconds, the position of the object is 70 meter. Here the speed will be 70 minus 45 by 40 minus 30. This is equals to 25 by 10. This is equals to 2.5 meter per second. Next is 50 meter per second. Here the position of the object is 100. So the speed will be 100 minus 70 by 50 minus 40. This gives us 30 by 10 is equal to 3 meter per second. Next is 60 second. After 60 second, the position of the object is 150. So speed will be 150 minus 10 by 60 minus 50. This gives us 50 by 10 is equal to 5 meter per second. Now my dear students, as you see that here the speed of the object is non-uniform. 2 meter per second, 1 meter per second, 1.5, 2.5, 3, 5, etc. So here the speed of the object varies with the passage of time. Therefore, it is an example of the non-uniform motion. Now take another example, another type of motion, that is the average speed. What is average speed? When a body moves with non-uniform speed, then the total distance traveled divided by the total time taken is called the average speed. The total distance traveled divided by the total time taken is called its average speed. It is expressed by VAV, and its SI unit is meter per second. The formula for the average speed is total distance traveled by total time taken. We can write here VAV is equals to S by T, where S indicates here the total distance traveled and T total time taken. Now take an example for the average speed. A car travels from Singrauli to Varanasi about 220 km in 5 hours. Find its average speed. Now in this case the total distance traveled is 220 km. Total time taken is 5 hours. Therefore its average speed will be VAV is equals to S by T. This gives us 220 km divided by 5 hours, or this is equals to 44 km per hour. So in this way, my dear students, we can determine the average speed of any body which moves with whose motion is non-uniform. Okay, thank you. Do the practice with some other examples. I upload some more questions